Hey, folks.
Hello, Luca. How are you?
Good. Lots of stuff to do, as I mentioned, for the upcoming Falco release. So many features. Every time so many features gets in, so it's it's cool to see, but a lot of work to do. There's a lot of people that are working on it right now.
Yeah. Are you responsible of releasing the Falco CTL as well, in addition to Falco?
Yeah, this release will contain it, and I will, and of course, I'm making sure that everything is getting in, is getting in and works. And this release contains Falco CTL alongside Falco. So yes, of course, the short answer is easy.
Nice.
And that's because, Falco CTL is known, has been known for, well, has existed for a while and has gotten the new features that are related to downloading artifacts and stuff, and the rules and plugins and stuff recently, a few months ago. But if we don't include it in the Falco release, then people, of course, will have a hard time trying it and testing it. So it needs to be there. And also the rules, we want to eradicate the pain point that we have, the fact that the rules are essentially now in the image itself, while you probably want either to use the Falco repository for rules that we now have, or to maybe you want to set up your own. And this is something that this thing enables you to do. And people before did their own servers, which is cool. But if there is a solution that the community likes and accepts and can work together on, I think it would be better.
Yeah.
Cool. Let's see. Of course, we're going to wait for a little bit for people to join. And again, I set this up as weekly, but remember that if there's not a lot of people, or we want to wait to discuss something, it's like in the regular Falco call, we can take less time if necessary. Nobody is, let's say, is making us compelled to do anything on this side. Thanks for joining, Roberto, Sumit, and Thomas. Let's see.
Hi, Luca.
Hello.
Hello, folks.
And also, I will call you developer guy, but also, do you happen to know if when you and Futkan would be able to work on to present what you know about the supply chain in total, and all the signature, let's say, sorry, keyless signing.
Yeah.
If you have a date on these meetings, and please tell us, and so that we can make sure, because there's a lot of people that is interested, so we can make sure everyone knows about that.
I think the biggest problem is that the language barrier I have. So I know all the topics, right? Because I am one of the contributors of the cosine. But when I start to tell about cosine, I didn't know much vocabulary in English. So I always tries to remember the words I need to say about the cosine. But I am more like a technical person, right? I am really like to make contributions on that project, but of course we can make some presentation, especially today. Actually, we can work with cosine project in local environment and discover what are the benefits of using cosine, and also we can talk about the OCI and OCI artifact stuff. But remember, I don't have much vocabulary information in English, so I am always tries to remember what I need to say in English. So okay, if it's okay for you, I can definitely make a demo about cosine and all the other things related to cosine.
So you say that you would be willing to do it even today, right now, with us in this call. Well, I think that's very cool. Fortunately, this call is recorded, so of course,
of course.
if you agree. And so I think we can actually start. So people, I know that a bunch of people cannot join, and they will be able, and a lot of people are interested, so they can take a look, and maybe we'll have questions for the next time. So thank you all for joining today's edition of the call of this brand new working group about the Falco supply chain security. As usual, I wish to remind everyone that first of all, this call is part of the CNCF project Falco, so all the CNCF code of conduct applies, and as usual, like in the Falco call, we are always nice to everyone else, and of course we're going to record this call for very good reasons, especially the fact that today developer guy is going to show us a lot of cool technical content. So if you don't want to show your face, you can just switch off your webcam, and so we can start. So basically, the topics that I had in mind, of course, were continuing the discussion, and so I think we can really hear from our developer guy, and oh yeah, and thanks for the remark, Thomas, about what you were saying about your English. As you know, we are all technical people here, and I believe, I'm not sure, but it's even possible that none of us is a native English speaker. So we completely understand, and we are
yeah, I will try my best.
Yeah, we are always nice. Just if I don't understand what you're saying, or if anyone doesn't understand, I think we can feel free to just nicely ask for to explain. We all understand technical, so don't worry, and we are only super happy to have you here. And and yeah, and also it's great that we are here. That not actually everyone is here, because I think there were some topics that I really wanted to discuss, for example, with Fred, who has been working on some of other topics. So it's great. If so, now without further stuff from me, if you wish to tell us about Cosine and let us see it, floor is yours. Thank you so much.
Yeah, thank you so much. First of all, folks who are not familiar with the Cosine project. The Cosine project was started by the Dan Loreng. Dan Loreng, who has been worked in Google for many years, I guess. So it was basically start with his own personal project, basically. But then, actually, at that time, there were less solutions to sign container images. Actually, there is a project called Notary, created by the Docker project, but the things that people are complaining about the Notary project is that Notary project requires the additional database to store signatures. So you need to maintain an external database to basically store the minimal signatures into that store. Okay, this is the biggest problem that Notary project has. So Dan Loreng is basically started this Cosine project to use OCI container registry to store signatures. This is the biggest and utmost important difference between the Notary and the Cosine project. So he didn't invent any additional storage to store these signatures. Just he used OCI registry to store these signatures. But before diving into the Cosine project, we need to understand what these signatures look like. So because there is no concrete type of thing called signature, right? Because signature is more like it's not a concrete thing that we can store on our disk or any other space. So basically, we are going to understand how Cosine create these kind of signatures and store in OCR register. We are going to start with that first. So basically cosign, this is the cosign's motto. Cosign is assigning OCI containers and other artifacts as well using SIG-Store. Basically, the naming is short form of container signing, right? This is the name. This is the name comes from container signing. So yeah, basically. Cosign aims to make signature invisible to infrastructure. Cosign support these kind of things, but the most important the feature that Cosign provide is the keyless mode. Basically, this eliminates the managing this public and private key pairs on our own. So this is the most important feature that Cosign provides for today. There's a thing called record. They call it as immutable ledger of something. I don't remember, but it's quite important project. It's basically a append-only database, provides a timestamping features in it. Yeah, they also provide a full CO project. Full CO is pre-certificate authority provider. They basically provide some signing certificates on demand. These are all maintained by the SIG-Store team. They are part of the keyless signing. So we are going to talk about in a second about the keyless signing, but yeah. Okay, let's dive into the cosign and learn how things work in cosign, basically. So as a demonstration, we are going to create we can create a key pair, and then we can use this key pair to sign container images. Basically, we need to install cosign first. There are many different ways of installing cosign. For example, I prefer to use Bref. You can use Bref install cosign, and it will be installed on your environment. So yeah, let me switch back to a simple Co project, and let's start with signing this container image first. So let me first build a container image with Co. If you are not familiar with Co, is a container image builder provided by Google for many years, but today it moved its own repository. I am one of the huge fan of Co. Co basically it helps us to create container images easy, fast, and secure by default. I am using Co on my daily job, so I really like to work with Co. So I am going to demonstrate how Co works in my local. So here is my repository. Let's build a container image first. Then we are going to sign it with cosign. Then we are going to discover what the signature is look like and how things actually works under the hood. So it's important to understand that the signature is nothing more than a JSON document. So when we are talking about the signature, and while we are talking about the signatures, we are going to take a look at the OCI stuff and other OCI artifacts things as well. So let's wait and wait to be completed this pushing container image. Yeah. So okay. So the first thing that we need
to do. Can I stop you right there? I have a question. Yeah. So when you did this with Co, I have never used Co. So yeah, when you did this, what is happening here is that the developer guy / hello world Co.
Yeah, this is my Docker Hub. This is my repository actually in Docker Hub.
So it's just a Docker image. It's pretty much the equivalent, I would say, to putting. I guess it's a bit different, but the same idea would be to put a Docker file there that says "go build," and then and then add the whatever it's needed. That's it. So we have any container image would do. I'm saying this, of course, because as you know, in Falco, for example, and many other projects, we cannot use Co just because it's our images are not Go. Like Falco is not written in Go. So,
Yeah, yeah.
so this
I
is
saw that Falco said written by Go. Yeah. We can definitely
yeah.
use
So, for
Crow in here.
example, doing an image for Falco, just for Falco CTL that uses Co is possible, but unfortunately, an image, for example, for Falco or Falco
Yeah.
Falco CTL wouldn't be possible. Please continue.
Yeah. The biggest advantage of using Co is that it doesn't require any running Docker daemon and any other Docker files at all, because writing Docker files is easy, but making it an efficient is hard, right? Because people already knows how to write a Docker file, but if you consider to make it performant and cache efficient, you need to know something something additional. For example, multi-stage builds, for example, selecting minimal base images, this kind of thing. So you need to be expert of the Docker file. So in code, you don't need to know anything about how you can build a container image at all. So it basically provides all other secure features by default, and it also publishes an SBOMs for us. And I saw that you already used Docker build X in Falco CTL to build a container image. It basically requires a QEMU, right? You need to emulate the CPU architecture that you target to build your container image for, right? In Go, you basically use the cross compilation feature of Go.
Yeah, that makes total sense.
Yeah. By the way, Go is just for Go applications. You can't use it with any other projects that you didn't write with Go. So yeah, let's start with first the keyful. Basically, there is no such thing keyful or keyless. These are the terms produced by the Sixtor team. That the solution that they provide. If you say keyless, it makes more sense for most of the people that they trying to do. So there is no such thing keyful and keyless. These terms are the jargons provided by the Sixtor. Okay. So first of all, we need to start with creating a simple public and private key pairs with using cosine generate key pair command. Once we do that, it will ask us a password that they going to use as a passphrase of my private key. So let's say 1. Okay, 1. You notice that there are 2 files to be created in my local environment. These are the files that are created with the cosine generate key pair command. Okay. Basically, this key that we are going to use to sign our container images, and this is the key that we are going to verify the signature against that container image. Okay. So this is the key that we need to manage on our own. We need to make it. We need to make it. We need to store this key in a secure way, right? So we need to manage this key. So we need to distribute this key to our customers or any other client that's going to use our software. This key is the key. Actually, the key that our customers need to verify our signature. So once you, there are a lot of available commands in cosine. Yeah, this is too much. So basically, the first command that we run is generate key pair to generate a simple public and private key. The next command that we are going to use is the sign command. So yeah, this is the sign command, and there are so many examples in the description you can find. Basically, we need to say that cosine sign and use that private key and sign that image. Okay, this is the thing that we need to run as a next step. So once we do that, he asked me my private key's passphrase, so I entered it, and the process completed successfully, right? So as we notice that the exit code is 0. So cosine basically says that pushing signature to this one, but it doesn't tell the whole story for us. Yeah. So once we do Crane LS, is for who are not familiar with the Crane project. Crane project is also another project provided by the Google that help us to work with container registries on our local environment. So it really makes the process easier for working with container registries, right? So here is the Crane project. These are the main tools that I used my daily job, Crane and Co. This is the Crane project. They also provide a Brief formula you can basically install with Brief if you are using macOS. So basically, when I say Crane LS, it will list all the text of that image. So you might notice that there are some additional text that this one created by Co and this one created by the cosine. But as a next step, we are going to take a look at the signature tag and how the signature is going to look like stored in this image tag. So I need to find the digest of it first. So this is the next command that I am going to run to find the digest of tag. Don't forget cosine creates an additional tag to store the signatures. You might notice that this is the digest of the image that I was built with Co. So if I say that find the digest of an image, this is the digest that we are going to get.
So first of all, Crane LS retrieves the tags from the remote repository, because if I see pushing signature to index.docker.io, it means that it's already there. So if I actually run that command on my machine, Crane, I don't have Crane. Maybe I can install it. I think so.
It's a similar tool for Scopio, yes.
If I were to install that command to my machine, I would get the exact same output that you're seeing, because those are just tags, simple tags for images.
Yeah,
that's right. Cool.
Yeah.
Thank you.
Yeah. If you remember that I was mentioned something called soft reference, right? You see the soft reference here. Soft reference means cosine basically associates that signature with an image by creating a special tag of an image, as you saw here. This is the thing that cosine assumes that when I verify that signature, the next command that we are going to run is verify. Cosine basically look at the digest of my container image, and then it's going to take a look at the tags to find the equivalent of that digest. Basically, this is the signature. Okay, so let's see how signature is going to look like stored in this tag. By the way, if we take a look at the manifest of an image, I'm going to show you something. This is the OC image is going to look like once we see its manifests. And you will notice that the signature is going to look like similar to the left one. Okay, so I am going to write the Crane manifest for signature right now. So first of all, I need to find the digest of the tag. This is the digest of the signature image. Okay, so when I set Crane manifest to that signature image, you will notice something in the signature. This is the annotation, basically stores our signature. But as a next step that we are going to see, we basically see the content of the signature. But in cosign, basically you can sign several times your container image with the same key. And every time it creates a new signature about your image. Okay, let's sign one more time. But it doesn't create any additional tag because there are already a tag associated with the signatures of an image. So it basically adds that signature as an additional layer of an image, same image. Oh, let me follow. Okay. I need to find. I think I need to find any. Okay, no problem. Okay. So let me basically run one more time. You will notice that cosign uses the same OCI standards for the signature, as you saw here. These are the media types created by the OCI image specification, so it's totally compatible with the OCI standards. Any command line client that works with container registers today can work with cosign signatures today. Yeah, there is a new media type that says, okay. If I remember correctly, that these media types is also registered to IANA. You are already familiar with IANA? Have you ever heard?
The Internet Numbering Authority.
Yeah. I think these media types is owned by the cosign, owned by the SIG-Store members, I guess, if I remember correctly. So, okay, let's see what it's actually stored as a signature in that image. So if I create blob and give that digest into the command, I will see the signatures actual content. As I mentioned, we need to see a JSON document created by the Red Hat community. If you remember, we talked about in early in previous meeting. Yes, Red Hat content. Yes, this is the structure that we are going to see in a minute. Yeah, this is the signature that cosign basically creates for our container image, and you will notice that this is exactly the same content that Red Hat creates in 2016, right?
Mm-hmm.
Yeah, this is the signature that we are talking about, and the cosign creates for us. There is nothing special about signatures. They call it as a signature, right? And they stored it as an additional tag in OCI registry. So yeah, this is our signature, and they stored it in a container registry as an additional tag.
Okay, sorry, can I stop you for a second there? See, first of all, I see that there is an additional tag, and you asked for the manifest of that tag. For the manifest, and in order to do this, you have asked specifically for manifest of an hash, because because you cannot do it directly with the tag. Because the tag, actually, I was expecting the manifest of the tag directly to appear with the signature, with the signature tag. You would ask for the manifest, and I was expecting it to appear there, but it's not that. Is there another layer of interaction, or is that just the fact that it's just the way Crane and container tools work, that they require a hash? Or is it the only thing that is there? Because I see that you put manifest developer guy hello world and @hash.
Yeah, it also works with also work with tag.
Okay, cool.
Yeah, there is no such restriction about using this digest or tag. Yes, it will work.
Cool, great.
Let's see.
Second question, you said that when you sign something twice, you're not actually getting, sorry?
Yeah, I agree. If I remember correctly, there should be an additional signature stored in the same layer.
Yeah.
Yeah, but maybe, yeah, go ahead.
Should that be in the same? So the tag of the signature is going to change pretty much. So if I try to apply another signature, then I get a replacement of the same tag that I had before, essentially. So this is the, oh yeah, great. This is.
It also works. It also works.
Okay, cool. Thanks.
Mm-hmm.
And yeah, and the other question was basically, I know that normally the layers have contents. Here you have shown the annotation rather than the content. Do we need to care about it? Is the content of this layer something that's important, or is all the signature being stored in this annotation?
I don't actually I don't know what is the exact value of that signature, but it might be a private key. No, there is no private key. Yeah, actually this signature is basically the equivalent of the this content, and basically if we sign this content stored in here with private key, this is the signature that we are going to get.
I think I get it. I believe the content itself
in this layer, yeah,
is
what
we're signing.
We are going to get signature.
Basically, where the content is what we are signing, and the content somehow is does the content here need to reference the original image? Because I guess it's going to probably be maybe the manifest, not the manifest itself, because it's 259 characters. I think that would be, that's probably, that manifest is much more than that. So so it's signing the content that is being signed. It's something that pretty much passes to the image. Sorry.
Basically, the content. Cosign basically creates the content stored in this layer, and it uses our private key basically to sign that content stored in this layer, and the signature that we are going to get is the end of that result.
Okay, that's very cool. My question is, what is the content of this layer?
Yeah,
and yeah,
this one.
Oh, that's cool. So it's the reference to Docker and the manifest digest. So the manifest digest is supposed to match there. It's a 05E, which I guess it's the digest of that manifest of the original image that we signed.
Yes. Things getting easier when you are talking. Yes.
Sorry?
Things getting more easier when you are talking in English.
Yeah, absolutely. And yes, that matches perfectly. That's exactly what the link that I wanted to say to see. And the annotation is the signature, while of course it's signing the annotation is probably signing this content, just the hash of this content, which is the other thing that was in the manifest as digest of this and as the layer, and we're good. Now we have one piece of metadata that tells us what is signed, and of course here, and what I don't see here, I guess, is of course the public key, because the public key needs to be imported separately at this point, I guess, because we had, you remember that .pub file that you generated? In order to verify this signature, I'm going to need that, and that I need to distribute separately from this image.
Yeah, you are right. Basically, the cosign public, this key basically that we are going to use to verify that signature created by cosign with the private key here. So you got me right. This signature was created. Let me see the manifest again. The signature created by signing this content with this private key. As an end result, that we are going to have this signature. You will see that as an annotation of an additional layer here. So once we verify that the signature, this is the signature that is going to be verified again, this public key. So we know the digest and we know the private key that were used to sign our container images, and this is the signature. So we have all the things that we need to verify, right? So once we do cosine verify and with the key, but this time we are using the public key, we need to specify the same image that we are signed. So let me type it to JQ. We are going to get a successful response back. Yeah, you see, you might remember that content. This is the content that cosine creates and stores in additional tag. This is the content, and this is the response of the verify command. These are matched.
And here it says the following checks were performed, cosine claims were validated, and the signature were verified against the specified public key. So that's all good.
Actually, the thing that the cosine output says the claims, because you can sign your container image with extra metadata. Maybe I can show an example how the things can work if we specify any additional metadata about the signature that we are going to create. So there is a thing called there is a flag called annotation. This annotation basically in here to let people add some additional metadata about the environment that they are going to run to run the cosine command. So you might notice that if you run on GitHub Actions, if you are running on GitHub Actions, you might add some GitHub SHA to your signature. Let's do an example and talk about let's say XA, I guess. Once we do that, we need to get an additional response back, because if we let me show you. You notice that we created an additional signature, but we don't get any additional text for it. So see, there should be a one tag related to the signature, but you will see that there are two layers right now, because cosine doesn't create any additional tags for storing signatures for the same digest. Because the digest is nothing changed, there is no need to create an additional tag for storing signatures because the content is the same. But we signed our image twice, but this time we are used additional metadata. It basically adds another layer to the same image that we specified here. But this time, once we basically, you will notice that the content of the layers are different. This is the first content we created, and this is the second, and these are different. So if we take a look at the second digest of that layer, so let me show you. Once we see the output, we will see the extra metadata in the output. See?
There it is.
Yeah, cool. Yeah. If I remember correctly, there should be something called signature in the documentation about how things work in general.
Cool. So one can add whatever information, additional information they want to the signature. That's going to be signed, actually, to the content that's going to be signed.
Yes.
Okay, so that's super cool.
There should be a file
Yeah.
called signatures. Yeah, this one.
I'm actually surprised that the Opera browser still exists.
Yeah. This is the signature specification that they explained everything in detail. You will see that there is a thing called yeah, this is the specification that they provide to store signature, this one. And you will see that all the things that are already explained in here. And what I'm trying to say is that this optional field explained in this document. Yes.
Yeah, cool. Yeah.
This is the whole signature specification that Cosine provides. This is the way how Cosine it works actually, provided for providing signatures. You can use that information while you are verifying your signature. Remember that we specified XA full and XA and full and bar, if I remember correctly. But if I say full and bus, it's going to fail. Let's see. Let's see. These are actually metadata that can help you to add additional information to your signatures. Yeah, see. And with that, you can guarantee that this signature was created by the GitHub actions that you run to your to build your container image, for example, something like that. People use this kind of informations to add additional information to their signatures and use them while verifying the signature in later stages. Yes. Basically, this is the keyful approach, and things getting a little strange while using keyless mode. So
and that's what I was waiting for.
Yeah. So let me find my record client. There is a CLI tool called Record CLI, if I remember correctly. So this is the Record project. They bundle all the artifacts with that. There should be a Record CLI in the releases, if I remember correctly. Yes. Let me.
Yeah, it's not. It was missing a sudo.
Sudo access.
Well, you can just copy it.
Yeah, I have already downloaded.
You already had it, probably.
Yeah. But I don't know which version I am actually installed.
It's old. It's older.
Yeah. not user bean, user local bean.
Yeah, I think it's SAP, the System Integrity Protection for macOS, that's blocking it.
Yeah, cool. We are going to need the record CLI to
Okay.
basically inspect all the signatures stored in the record. So
A
yeah,
record is basically a database, and that you
yeah,
and yeah, of course, maybe it's a hash database with like hash pointers and stuff, but it's basically a database at this point.
yeah. Basically, the record is just for your customers to see, to see your actual status. Basically, what I mean by saying status, if you basically they can monitor your releases signatures through the record to see basically you got hacked or not.
Mm-hmm.
This is basically the record intention. So record is just for your customers. You might think that you are providing some software solution and your customers need to know that you didn't get any tampered with your releases. This is the where they, this is the thing that they were take a look the status of your basically the health of your releases is record. So yeah. Let me switch back the signing keyless mode. I think they probably going to remove this experimental flag that we need to specify for today with the cosine v2 release. They are preparing a new release of the cosine and they are probably going to remove the experimental option because if I remember correctly, Sigstore already moved to GA, so they probably provide some SLOs, their public good instances, record and full zero. If you search with this one, yes. They called it an experimental features because they didn't provide any uptime guarantee for that services, full zero and record that I am going to say yes. So once they provide their availability about their services, they going to remove this experimental flag. But today we need to beat that flag to enable keyless signing mode.
Cool.
Yeah, so basically it eliminates to require specifying the key option. So once we do a keyful approach, we need to specify the which key that we are going to use as a private key. So basically once we enabling this keyless option, we don't need to specify this key. So this is the difference between the keyful and keyless approach. Actually, there are so many things. There are so many different things about this keyful and keyless approach, but at least at the command line level, it eliminates basically this key flag. Okay.
Cool.
So what is going to happen? So
okay, let's
yeah, this is an important important description, let's say, because once you do that, basically you are using some public service, right? So the signature is going, yeah. If you are using a private project and don't want to expose it to the internet, basically, you need to start your own private instances because there are great documents exist to basically tells you how to spin up all these FUSIO and record on your own organization.
Sure. So there's the record database is public. So, and it's also made it to be tamper proof. So whatever we push there, it's going to be there for eternity. That means,
yeah.
And, okay, eternity might be a strong word, but as long as the thing is live.
Yeah. So basically, so let me. Okay, let's say it
Yes. And now I'm very curious where it's going to connect.
If I remember that it basically provides some signing certificates from Pulsio, but things getting a little bit easier when we inspect the certificate created by Pulsio, because once I log in one of the options from the website, Cosine basically opens.
So did the command line open this page for you, or did you find it?
Yeah.
Okay.
Yeah, because basically Pulsio creates signing certificates, but the important thing that we need to notice that Pulsio embeds our email address into the certificate itself. This is the thing that you need to trust. You need to say that I am let's say I am the provider of the software, and let's call me as X company. Once you verify the signature, if I used a keyless approach to create those signatures, you need to trust the email in the embedded into the certificate to basically verify that this product is coming from our trusted entity.
Makes sense.
Named X company. Yeah. This is the first step that we need to prove that I am the owner of that email.
Sure.
Yes, let's say login.
Log in with the GitHub,
yeah.
And we're back. And accessing identity. Deadline exceeded. You probably just waited too long.
Maybe.
No, or it had some problems on its own. Because the command line stayed there for 3 minutes.
Yeah,
let's.
Yeah. Sorry. Yeah, you're probably right. Let's say yes.
You just say yes, and when you get the page, you just click, and we should be there.
Yeah, this should work right now.
Okay, so we are doing keyless signing, push in signature, and now we have a signature just like before, essentially.
Let's change something. Let's do a cosine clean first. I just wanted to show something to you. Let's do a cosine clean. Basically, cosine clean clears all the signatures associated with that image, because cosine already knows that signature stored in a separate tag, so it's going to remove this tag from OCR registry, right? So basically, once I do crane ls again, once I removed all the signatures, I will get nothing. You see there are no things about signature in the tags of an image. Okay, so let me reassign my container image with keyless mode. I just wanted to show you signature is going to store in record, not OCR registry itself for keyless mode.
Okay. I got you.
Yeah. Once you use the keyful mode, cosine uses OCR register to store the signature. But once you use the keyless mode, it's going to use the record transparency log to store signatures. Okay. This is the second difference. Yeah. Let's do a crane ls again. We need to make sure that there is no signature tag associated with that image. Basically, it's also pushing the signature into the OCR registry in addition to the record.
Couldn't that be the previous one that was already there?
I removed, this one. See,
oh
there
yeah,
is no
right. You removed it.
Yeah.
You removed it. Okay.
Yeah, also, the signature is also stored with an OCR register along with the record itself. I didn't remember that. Yeah. But we will see the signature stored in the record in addition to OCR registry just in a second. So
yeah, you just pushed it. Yeah, definitely.
Yeah, the first thing that we need to care about is that the login text in here. T-log entry created with the index. This basically you can think of it as an ID of your record in record transparency log. Okay, this is the first starting point that you can use. In record CLI, let's search that index in as something better. There is a project record tlog.dev. Basically, you can do the same thing that I am going to do in a minute. Basically, you can open that website and use that tlog entry to see all the things in record. Select the log index entry, log index attribute, and put the put my ID into that, and you will see my entry in record. I just want you to notice something in the entry. You will see that my email is associated with that certificate, right?
Yes. And OIDC is GitHub.
Exactly. If I were login with the Google one, things is getting changed in here. We will see the Google's issue in here. Yeah. Basically, once you sign something, this is the thing that your customer is going to trust. This email in here. So this is the say that I am the owner of that signature as a owner of an email here. So we basically say that I created those signature by this email here. So in the first step, you remember that we log in with the GitHub or any other additional OIDC provider. So we basically prove that we are the owner of that email. So if I am the owner of the email, I am also owner of that signature, and you can trust me. You can trust my products by verifying the email associated in the
of course
certificate in here. Yes. But there is nothing much to see in here. So we are going to see the certificate itself and the signature by using the record CLI. Record CLI basically helps to find.
I have one question here.
Of course.
So when you're talking about the email, it is possible, let's say for Falco, to have a custom email for image signing.
Exactly.
And use that for performing this operation.
Yeah, definitely. That's a good point. This is the way Tecton Chains provides their signatures. Let me show you something. I think this is probably going to answer your question. Once you visit the Tecton Chains project, are you familiar with the Tecton Chains project? Maybe we can. Yeah, Tecton Chains project basically supply. I wrote a blog post about Tecton Chains. Things getting easier when I write blog posts. My problem is talking in English. So yes, this is the blog post that I wrote and published in CD Foundation. It's going to help you to understand all the things about the Tecton Chains, but never mind for now. There should be a releases page in Tecton Chains, and it gives the exact commands that we are going to verify the releases of the Tecton Chains. And you will see that they're also using some keyless approach. So here is the, how can I verify the signature? The record UID, yes. There are additional options in here, enter UID. Once you use the UID, you will get the same exact output. I need to find the
email.
Yeah, I need to find the email. Yes. Yeah, let's. How can I get the email? So let me. Sorry. I need to give the exact number of the UID index here. If I remember correctly, they using a service account. They were created for signing, killer signing the Tecton Chains releases. There should be something in Google Cloud service account token, if I remember correctly.
Okay, I have a follow-up question on this. So, I mean, in terms of email, Falco organization has a bunch of emails that can be used for this. One example is Poyana, for example. That's the bot. So you get the bot email because the bot is the one that ends up doing the actual release, or if necessary, there are some email addresses with Google accounts and so forth that can be used for this. The other question is how is this working in CI? So before you had to authenticate GitHub from your own account, but what if I'm in a CI/CD? Because for Falco, there is going to be a CD that does this. So for example, GitHub Actions, it's going to do the release. How is it going to authenticate to provide authenticity of this?
Yeah, that's a good question. But just give me a couple of seconds. I never exit from Vim. Yes. Let's verify the signature of the image provided by the Tecton chain. The things that we see in here is something called SLSA provenance, right?
Okay.
Yeah. This is not the signature of the Tecton project. It basically provides the attestation also. But now we are going to see the now we are going to see the email address. It's not sign verify, sorry. I think there should be a good way of searching in record. Oh, they didn't sign the controller. I didn't expect that. There should be a signature. Why? Yeah, I think this should be, yeah, the same one. I surprised with that by they didn't sign their container images. It's interesting. They only provide some attestation. Yeah. Or maybe we can change it with the chain guard images. Maybe we can see the service account in chain guard images. So let me I appreciate you. Hossein is also using this issuer in here. Basically,
Okay.
yeah, this is coming from the Tecton chains, not the Google's one. Oh, I found an important, a great example. Why we are not using the Kubernetes components to verify the signatures. Let me find an, yes. You will see the commands that we are going to run to verify the Kubernetes artifacts in here. So basically, once we run that command, we will see the
Okay.
email information of the Kubernetes users, and we will see the Google. I hope we will see the Google. Yes, this one.
Okay, accounts.google.com.
This is the email that I think Kubernetes uses. Krell, the short for Kubernetes release, I guess there should be a command.
Of course, trust at G service account that I'm guessing it's the Google is something that can be created via Google clusters, because iam.gservice account, I guess it's Google Cloud.
Yes, I guess. This is
probably it's not actually an email address that you can write to, but it's an identity that's created by IAM for Google Cloud. Maybe.
Yeah. The second question was.
The question was simply since we're over time, we're a bit over time, and maybe people have other things to do. We can actually continue also next time. But the simple question was, how about we use GitHub Actions? Since, for example, if we use GitHub Actions to release, can we have this authenticated directly with GitHub Actions?
Yes, exactly.
Cool.
This is the magic behind the keyless signing while you are using GitHub Actions. You don't need to do anything because GitHub provide their OIDC information to the Fusio to get basically the signing certificates.
Okay. So
let me share some documentation about that.
Absolutely. So this was really helpful and informational for me. So thank you so much for going.
Thank you.
Thank you. Really, thank you so much. This is awesome. Like I thought this is great to have all this information just for us and for us and everyone who's interested. Just thank you so much for your effort showing this to us. This is very, very helpful for everyone. So I just posted all the references that you just put in Zoom. I posted them in the agenda so that everyone can take a look. If you think there are more things that we should know, and I think there are, we can continue.
Yes.
And we can also, everyone that was interested can also take a look at this and come back with questions, because we are already, some of us, myself and Sumit, and I'm sure the others as well, were thinking how to apply this for Falco and for all our stuff that we are publishing and signing. Really, I don't know how to thank you. You did a great presentation on this, great tutorial, and you were so knowledgeable and actually showed us the links between all this stuff, because this is otherwise, especially for security people, that's meaningless. But if you actually are able to link hashes to signatures, this is really awesome.
Yeah, one thing which I had some questions during the presentation, but I think they got answered as we moved on. So I was thinking, how are we going to perform the proof of burden in this case? But you showed that with the transparency log, the proof of burden is publicly available and can be performed. So I felt like there were some questions I had in my mind, but they just got answered as we covered the subject.
Yeah, thank you.
Did Thomas, were you saying something? I think I heard something. No?
I think the wire scratched on my
Cool, awesome. Well, thank you everyone, and especially developer guy, like 1,000 times for this presentation and everything. We will reconvene on these topics next week, and we'll continue discussing this, and when I get the chance to review all this documentation that you just posted, I will also have probably more questions, because some of the stuff sounds like magic, and I want to know everything, including of course all the pitfalls that we might encounter when we deploy this to the Falco infrastructure. thank you everyone for attending. And as usual, the channels are there, Falco and the Supply Chain Security Working Group. And I think this is a great start for our effort. Have a good evening, a day, everything, especially for developers at 9 p.m. or something like that. So thank you so much.
Thank you. Thank you. See you.
See you.